Hi, this is Kayla and Bruce from 9CI. Thanks for clicking. If you are just new to us, this is one of our educational forums.
Right. Yes. Welcome. Hi.
We're also on SoundCloud, so if you'd like, you can follow us on that as well, 9CI as well. So thank you for joining us again, Bruce.
Oh, my pleasure.
Yep. So today we wanted to talk about EMF, electromagnetic fields,
right,
and their health concerns. So first off, we previously did a video on RF, radio frequency.
Right.
Can you elaborate as to why this is also a concern?
Right. Okay. So the term EMF, electromagnetic field, it's a generic term that can apply to microwave radiation and mag fields, right? So the term EMF, like I said, it can be applied to both. But in this case, what we're talking about in this video is mag fields,
right.
Fields that are generated from current flowing through wires. Microwave radiation is an electric field, just like an electric field is generated. There's an AC outlet behind the chair here. The fact that there's power on that AC outlet, that's generating an E field. The higher the voltage, the higher the E field is. But what we're talking about today is mag fields.
Right. Which are developed when there's a current.
When there's a current flowing. You're right. So in other words, people living, let's say, next to power lines, high voltage power lines, and I think, this is just as much of a concern for health as microwave radiation. It's just not popular to talk about right now because everything is the 5G awareness is increasing.
Right.
Right, and microwave radiation is the center of attention, but
it's the new popular thing.
It's a new popular thing, but there are a lot of people that are affected unknowingly by low frequency mag field, AC mag fields. Yeah.
So that's why this is a concern.
That's why this is a concern.
So how would you test for this?
Okay, so yes, meters. We're going to do another video. There's a way to test with your smartphone. And what was that app that you used for the RF heat map?
That was.
Yeah, we can talk about that in another video.
That app was Physics Toolbox.
Right, Physics Toolbox.
Right.
So all smartphones have a magnetometer in there, and it's a sensor that measures magnetic fields. And so what we're talking about how to measure is a dedicated device called a Gauss meter, and this particular one, NFA 1000, is a Gauss meter in 3 axes. So in other words, there's the X, Y, and Z axis, and it has 3 sensors to measure all those axes at the same time. Shows you the value. A less expensive meter from the same company only has 1 sensor, so you actually have to physically just change the orientation just to be sure that you're covering all the axes. So having a good tool to measure is really important, and it's amazing where you will find magnetic fields that you wouldn't
have thought of. Yeah,
right.
Pretty much anywhere where there's power, pretty much.
Wherever there's power flowing, right. So common sources in the house, refrigerators.
Those are always running. So
they're mostly running.
We hope they're running.
But let's say, for example, your house is laid out where you have a bedroom on the opposite wall of a refrigerator, for example.
Right.
Well, the mag fields when the refrigerator is running are really high, and
they take a lot of power.
So there's a compressor motor in there that's generating a mag field. These old school wall warts, I call them wall warts, but they're AC adapters. They have little transformers inside there, and the mag fields coming from those things are crazy. For example, if we turn on this little meter here, we plug. You can hear it. We'll put the
it's not
the
plugged
meter
into anything either.
Right, it's not plugged into anything, but the way a transformer works is the inefficiencies of the transformer. It's current's flowing through it whether you're using power on the other end or not. Transformers are not efficient.
Yeah.
So right now we're essentially almost at nothing for mag fields, but when we plug this in,
It immediately goes.
yeah, this is just over scale.
Yeah.
I mean, yes, it's actually thousands of nanotesla. So anyway, let's say you've got this one of these things plugged in near your sleeping area or by your bed. I mean, most rooms now have AC outlets. There's code for having a certain amount of AC outlets at regular intervals.
Right. For
Distances.
convenience.
For convenience
Yep.
and
So
stuff.
we're tripping over those cables.
Right, exactly. So let's say your bed is right near a plug, and you plug one of these things in there. And it's like,
And they
okay.
usually are, because you want one on either side.
Right, yeah. So clock radios, I don't know if a lot of people use them anymore. It's mostly smartphones that people leave on. But previous generations of people will have clock radios and stuff, and the mag fields that are kicked off from the power transformer inside those are significant.
Yeah.
Usually people have them like a foot or so away from their head. So anyway, it's a concern, and that's something that did affect me when I was growing up. Just unfortunately, we did another video about microwave radiation, right?
We did.
Right. So I didn't even talk about the AC mag fields, but I was quite a geek as a kid and played with electronics, and power supplies that I had for powering electronic stuff that I had in my room. I just kept the power supplies under my bed because it was just an easy way to get it out of the way.
Well, yeah.
Yeah, but
again, you don't want convenience. You don't want to be tripping on it.
you don't want to be tripping on it and stuff like that. Yeah, but okay, so you got this big power transformer from a old television. We'll show some pictures in this video of what I'm talking about. So that's sitting under my bed, and it's just like the mag field that's kicked off from that is crazy. And I was exposed to that for a long time, and so it not good. So I was
it's bad.
as a kid, and young adult, I had extreme exposures from AC mag fields and microwave radiation.
Which probably led to you becoming
sensitive. Absolutely.
So how would other people control their exposure to these if it's everywhere in their home?
Okay, so measurement's key, right?
Yeah,
so,
knowing where it's coming from.
So there's the good and bad news about this kind of stuff is that when you measure for AC mag fields, you can identify the sources very easily. Gauss meters are not really expensive. And technically they're much easier to make than good microwave RF meters.
Right.
Because Gauss meters, we're primarily concerned with really low ELF, extremely low frequency AC mag fields, which are in North America 60 hertz, and in Europe 50 hertz.
Yeah, for our European viewers.
Right. You'll notice some of the meters, these meters have a setting for 16 hertz. And electric trains in Europe, I'm not sure if that's still the case, but there was a period of time where the AC power that was feeding these trains was running at 15.7 hertz or something like that.
That's low.
So yeah, very low frequency. So there's options for that on these meters, but I think pretty much right now, if you're just talking about 50 or 60 hertz,
covers most of your the normal person's
yeah.
environment.
And then there's the first and second harmonics of that, but all these meters, any inexpensive meter will read up to 100 kilohertz with no problem. So anyway, you measure, and then you make adjustments. So you can move your bed to the other side of the room, for example. The same rule applies for EMF mag fields as it does for RF, the inverse square law for distance. Distance is your friend, okay? But the bad news with mag fields is that you can't easily shield. Right. Mag fields go through anything. They go through anything. There's materials called mu metal. You can buy mu metal shielding, but that's used to let's say we wanted to put a shield around this mag field. Well, we would put a mu metal cage essentially around this, but in the case of AC power lines that are outside, for you to actually shield your house is pretty much impossible. So if you're living near a high voltage power line or a transformer substation,
Yeah, so like if you had the option of where you wanted to live, would you live close to a power line, or would you choose?
Right. So there's that question from before.
Yeah.
Just as we would ask the question to people like, would you leave a microwave oven on all night, a foot or two away from your child's head? Most people would say no, right? But the microwave radiation coming from a baby monitor is the same, right? But the perception, because it's a microwave oven,
Because we know it's
right, it's the same. So now what I see, you ask anyone. If we show a couple pictures of two houses, one next to high voltage, high tension power lines, and another one out somewhere not near that. Which house would you choose to live in? Feel
free to leave comments, by the way.
Yeah.
If you have an opinion on the matter.
Yeah. I tell you, most people that I talk to, even if they don't know anything about all this stuff, would be like, I'll probably not want to live near that.
Yeah, even if it's just aesthetics. Like,
right.
You'd find a reason.
But when I was, I had a rental house for a while near one of those things, and it's very unsettling because, especially when it's damp outside, you actually hear the buzzing sound because the almost arcing down the insulators. So it can be another video if you want to know what kind of power, what kind of voltage is going through your power lines near your house. There's a way to calculate that based on the amount of insulator discs that you see, but that can be another video. We can talk about
more math. So there are a lot of different sources of this. You have discovered something interesting in older houses. Water pipes.
Yeah, water pipes. Holy cow. Okay, so it's an interesting time right now because there's two things changing. The infrastructure in a city used to be, there's a whole
different metals.
Different metals.
Built on different metals, yeah.
Right. So there's copper water pipes. There was concrete water pipes. Now everything's moving to plastic. In houses, there was a period of time where it was all just copper water pipes. Even before that, I don't know what materials, brass.
Probably.
In the last, I don't know how long, when did they switch to all plastic PEX water pipes? 10,
15, maybe?
15 years ago?
I would think.
So the disadvantage of copper water pipes is, in combination with AC power lines that are in the area, is that potentially you get conductive water pipes that are running alongside underground buried cable. So in many neighborhoods, the electricity service to everyone's home is an underground wire.
Yeah.
Right. So the problem there is that the induced current, by the fact that the water pipes are near the power lines, or even if the power lines are outside hanging in the air, there's going to be an induction induced current to your water pipes. And so my house, for example, was crazy. There's a short video that we can have playing or whatever, but basically there was a variation between 1.5 and 7 amps of current flowing through the main water line coming into the house, and that was a result of the induced current, ground current, stray AC mag fields or AC fields put onto the water pipes, and so it's just like, as a result of that current, mag fields are created as a result of electrical current flowing, not just a voltage. And as a result of that current, the mag fields in the house were crazy. Anytime you got near a water pipe in the house, the mag field would go up. So the solution was just to put a little insulator, just to basically cut the main water line coming in, and then just insert a section of PEX, and that solved the problem. So again, you would be able to identify that fairly easily with there are lots of different meters on the market.
Yeah, so modern homes don't really have this problem, but if you have a slightly older home.
Right, exactly. If your water pipes are copper, then just...
Or even, maybe you had a really different contractor and they used copper.
Right.
Which
yeah.
might not be very common, but...
Right, yeah.
How would you know unless you measured?
Right. So again, just awareness, right?
Mm-hmm.
Yeah. But for that, there is a solution.
Yes.
Yes. Unlike living near a high voltage power line and a transformer substation.
Right. So you've actually known a few people that have been close to this, and there are incidences of areas that have been highly exposed.
Yeah.
You mentioned one to me earlier.
My friend, she grew up in a smaller town, and in school, the term for the people living near this power substation in the city was called Cancer Hill. And from what she said, basically everybody that lived in that area, someone or multiple people in their family was dealing with some form of cancer. And it's interesting because she said even as a child, it was just sort of like, well, it was known in the town. It's like, well, you don't want to be living there because it's near that transformer. And it's just like, okay, so there are lots. Again, if you have heard of stuff like this, examples, please comment. But my experience is that you ask people about it, there are stories, right?
Right.
So that gets into the whole thing of the current safety guidelines,
which are a little bit different from what the Bio Initiative report suggests.
Yes.
We've got a couple different variables. We can show you them.
Yeah. Yeah. So if you look at building biology guidelines and looking at the latest science that can that's actually looking at cell damage and things like that. Just like in microwave radiation, the safety standards for AC mag fields are grossly inadequate and unsafe, and also in many parts of the world there really are no standards. I mean, we could pull up some documents here, but
Canada doesn't.
Yeah, basically in Canada, the standards only cover 3 kilohertz and up into the microwaves, and they consider ELF, extremely low frequency 60 hertz mag fields from power lines, as to be a non-issue. And yet you hear these stories of people living near power lines or transformer substations with health effects, but it's just like it's just not talked about anymore. And not anymore, it's just not talked about. Not talked about
in general, just because it's no longer on the radar of...
Yeah, especially now with the 5G awareness thing coming up, right?
So we can only deal with one crisis at a time. But if we didn't deal with it already, then it gets pushed to the side kind of thing.
Yeah, exactly. Exactly.
Anyway. Well, anyways, thank you for chatting with us again, Bruce.
You're welcome. I know it's another thing to think about, and it's just like as if the microwave radiation wasn't enough. But the reason I think that this is important is just that people need to be aware of this, just like RF. And so just get yourself a tester and do some changes. Mm-hmm. And if you live near high voltage power lines, especially in the summertime when everyone's running their air conditioners, that's when the mag fields are going to go up really high. Consider moving. If you're especially if you're dealing with health issues or health concerns,
or have a medical device.
Yeah, don't
puts you at bigger risk.
Right, exactly. Just consider moving. Get yourself a tester and then take it from there.
Yeah.
Yeah.
Awesome. Thank you so much.
Okay, Taylor. Yeah.
Thank you for sticking with us. Feel free to subscribe to us on SoundCloud and like our channel and leave some comments so we can find out how we're doing and what you are interested in. Thank you.